everyone. Today is my third video on the topic of vector calculus, and we'll be discussing the curl topic of the calculus. This is the content in which we have discussed in video 1, which we have discussed the gradient of vector. Second video consists of the divergence of vector. Third consists of the curl of vector. First of all, what is the curl of function? Here, the mathematical formation of curl f can be represented in the form of the cross product of del cross f, where del is the operator of the partial differential and f be some vector function. This f will be written in the form of f1 I cap plus f2 j cap plus f3 k cap, and del cross f can be written in the form of del, that is partial derivative with respect to x I cap plus partial derivative with respect to y j cap plus partial derivative with respect to z k cap cross your function, vector function, that is f1 I cap plus f2 j cap plus f3 k cap. To find the cross product of two vectors, we have to take it in the form of determinant, in which your first row is I cap, j cap, and k cap, and second row includes the second vector, that is del over del x, del over del y, del over del z, and the third row consists of the second vector, that is f1, f2, and f3, and we'll be finding out the determinant of this matrix, that is I cap is equal to del over del y f3 minus del over del z f2 minus j cap, that is del over del x f3 minus del over del z f1 plus k cap del over del x f2 minus del over del y f1. So in this manner, we can calculate the curl of any vector quantity. The physical interpretation of the curl, let us take it be V, can be calculated by taking, let us take the example of a fluid flowing in a three-dimensional plane. Here, let us take the fluid is moving with the velocity v, but this v consists of two components. Those are the angular velocity into the position vector. The position vector is the vector around which our function is rotating. Let us take that w is equal to w1 I cap plus w2 j cap plus w3 k cap, and your position vector consists of x I cap plus y j cap plus z k cap. Now, firstly, we'll be calculating the cross product of angular velocity into position vector. It will be I cap, j cap, and k cap. First vector will be w1, w2, w3, and x, y, and z. Fine. So the cross product will be w2z minus w3y minus j cap into w1z minus w3x plus k cap into w1y minus w2x. Now we will be calculating the value of the cross product of del into v. V is your omega into r. That is again the first row will be of I, j, and k unit vectors, and second row will be of this function, that is del over del x, del over del y, and del over del z. Again, you will be having the second vector, that is w2z minus w3y. Second vector will be w3x minus w1z. The third vector will be w1y minus w2x. Now again we will be calculating the determinant of this matrix, which will be I cap into partial derivative of y with respect to this, that is w1, right? And this, that is minus of minus w1. Again we'll be calculating similarly in the second manner. It will be omega 2 minus minus omega 2. So on. In similar manner, we can be writing 2 omega 3. So we are having 2 omega 1 I cap plus 2 omega 2 j cap plus 2 omega 3 k cap. And finally, we can write it in this manner. Means your vector velocity of the fluid is equal to twice of the angular velocity. Now we will be solving the same with the help of an example. Here we are taking this example in which your v vector is given in this form, and we have to calculate the curl of this vector at point 2, -1 and 1. For that, first of all, we'll be again calculating the cross product of del into v. So first row will include your unit vector I, j, and k. Second row again will be including your the partial derivative, that is del over del x, del over del y, del over del z. And the third row will be including your this vector, that is x, y, z, 3x square y, xz square minus y square z. Now we will be solving this for the unit vectors, that is ijk del over del y. It will be 2y, fine, minus 0 minus j cap. Again you will be taking this function with respect to x, that is z square minus xy plus k cap into 6xy minus xz. Now you are having the vector of minus 2yi cap plus xy minus z square j cap plus 6xy minus xz into k cap. Now you have to calculate this value at point 2, -1 and 1. Therefore, x will be replaced by 2, y will be replaced by -1, and z will be replaced by 1. So our function for del cross v will be equal to -2 into -1 I cap plus 2 into -1 minus 1 square j cap plus 6 into 2 into -1 minus 2 into 1 k cap. So here we are having the value of 2 I cap plus minus 3 j cap plus 12 and 2, 14 k cap. So this will be the answer for example 1. Now we will be again solving another example with the help of same procedure. That is, we have to find the vector this and show that Rn raised into R vector is irrotational. Irrotational means their cross product must be 0. So let us find out the cross product for this vector. But before that, it has been given that we have to take the modulus of this. It means it will be x square plus y square plus z square raised to power half. So our function is equal to Rn raised to R vector. Your Rn will be x square plus y square plus z square raised to power n by 2 into R vector, that is x I cap plus y j cap plus z k cap. This is now we can calculate the curl of this vector, that is f vector. So again, we'll be taking your determinant form. First row, similarly the unit vectors. Second row, it will be the partial derivative, that is del x, del y, and del z. And third row will be your f vector, that is x square plus y square plus z square raised to power n by 2 into x. X square plus y square plus z square raised to power n by 2 into y. X square plus y square plus z square raised to power n by 2 into z. Now, we will be solving this, or we can be expanding it in form of I cap. I cap will be del y. It will be n by 2 x square plus y square plus z square raised to power n by 2 minus 1 into 2 yz. 2yz minus n by 2 x square plus y square plus z square n by 2 minus 1 into 2yz again. Fine. So minus t cap into n by 2 x square plus y square plus z square raised to power n by 2 minus 1 into 2xz minus n by 2 x square plus y square plus z square raised to power n by 2 minus 1 into 2xz. Now the last expansion, it will be around k. It will be n by 2 x square plus y square plus z square raised to power n by 2 minus 1 into 2xy minus n by 2 x square plus y square plus z square n by 2 minus 1 into 2xy. So here you can see that this function and this function is having only same magnitude but different signs. So this will cancel out. Similarly, this will cancel out. Similarly, this will cancel out. So we are left with 0. This proves that our function is irrotational. And here we have solved the two questions for the curl, in which first we have calculated the curl of a vector, and second we have found it is rotational or irrotational using the curl theory. Then it ends our topic here. Have a nice day.